In this lesson, we will delve into the concepts of incomplete positioning and over-positioning within the fixture positioning principles of Project 2. Incomplete positioning and over-positioning are critical concepts in fixture positioning, significantly impacting the positioning accuracy and the machining quality of workpieces. We will explore their definitions, causes, practical applications, and how to properly address them. Additionally, we will learn about the engineering wisdom demonstrated by veteran craftsmen from Shenyang machine tool in this area. Incomplete positioning and over-positioning are critical concepts in fixture positioning, significantly impacting the positioning accuracy and the machining quality of workpieces. We will explore their definitions, causes, practical applications, and how to properly address them. Additionally, we will learn about the engineering wisdom demonstrated by veteran craftsmen from Shenyang machine tool in this area. Based on the degrees of freedom restricted for the workpiece, positioning methods can be categorized as follows: complete positioning, incomplete positioning, under-positioning, and over-positioning. Complete positioning. This is a positioning method where all 6 degrees of freedom of the workpiece are restricted. For example, when machining all 6 faces of a cube, complete positioning is required to ensure the workpiece's position is accurate in all directions, thereby guaranteeing machining precision. Incomplete positioning. This is a positioning method where fewer than 6 degrees of freedom of the workpiece are restricted, yet it still meets the machining requirements. For instance, when milling the top surface of a flat plate, it is sufficient to restrict the workpiece's 3 degrees of freedom, Z, X, S, and Y. This is because fixing the plate's position in the vertical direction and its rotation around the X and Y axes is enough to complete the machining of the top surface. Under positioning. This is a positioning method where the degrees of freedom that should be restricted are not fully constrained. Under positioning is not permissible because it can lead to compromised machining accuracy. For example, during drilling, if the workpiece freedom of movement is not properly restricted, the position of the drilled hole will be inaccurate. Over-positioning. This is a positioning method where a degree of freedom of the workpiece is redundantly restricted by 2 or more positioning support points. Over-positioning can lead to unstable positioning or deformation of the workpiece. For example, using 4 positioning points to support a workpiece on a plane may result in over-positioning, as 3 points are sufficient to define a plane. The additional point may exert extra force on the workpiece, causing deformation. In the machining process, fixtures play a crucial role in ensuring that the workpiece occupies the correct position on the machine tool, thereby guaranteeing machining accuracy. Within the principles of fixture positioning, incomplete positioning and over-positioning are 2 concepts that require our focused attention. Incomplete positioning refers to a method where, based on the machining requirements of the workpiece, it is not necessary to restrict all 6 degrees of freedom. Instead, only some of these degrees of freedom need to be restricted to meet the machining requirements. In actual production, incomplete positioning is widely present and considered reasonable. Theoretically, a rigid body in space has 6 degrees of freedom, translational degrees of freedom along the X, Y, and the Z axis T, X, T, E, T, Z, and the rotational degrees of freedom around the X, Y, and Z axis R, X, R, E, R, Z. However, in many cases, it is not necessary to restrict all 6 degrees of freedom for the machining of a workpiece. For example, when milling a plane, it is sufficient to restrict the workpiece's translational degree of freedom along the z-axis T, Z, as well as its rotational degrees of freedom around the x-axis R, X, and the y-axis R, L, to ensure the machining accuracy of the plane. As long as the workpiece's position in the z direction is fixed and it does not rotate around the x and y axis, a plane that meets the requirements can be machined. Another example is when turning the outer diameter of shaft-type parts. Typically, it is only necessary to restrict the workpiece's rotational degree of freedom around the z-axis R, Z, its translational degree of freedom along the z-axis T, Z, and its translational degrees of freedom along the x-axis and the y-axis T, X, T. This is because the machining of the outer diameter of shaft-type parts is primarily accomplished through the rotation of the workpiece and the feed of the cutting tool. As long as the rotational center and the actual position of the workpiece are correct, a qualified outer diameter can be machined. The advantages of incomplete positioning lie in its ability to simplify the structure of the fixture, reduce the manufacturing cost of the fixture, and simultaneously improve the efficiency of workpiece clamping. When designing fixtures in practice, we should reasonably choose incomplete positioning methods based on the machining requirements of the workpiece, avoiding unnecessary positioning constraints. Over-positioning refers to a positioning method where a degree of freedom of the workpiece is redundantly restricted by 2 or more positioning elements. Over-positioning can lead to issues such as unstable positioning of the workpiece, clamping deformation, or even the inability to clamp the workpiece. Therefore, it should generally be avoided whenever possible. Causes of over-positioning. The primary cause of over-positioning is the unreasonable arrangement of positioning elements. For example, using more than 3 support pins to position a workpiece on a plane can result in over-positioning. This is because a plane only requires 3 non-collinear support points to determine its position, and any additional support points will redundantly restrict the workpiece's degrees of freedom. Over-positioning can lead to several adverse effects. When there are manufacturing errors in the workpiece's reference points and the positioning elements, over-positioning can cause interference during the positioning process, preventing the workpiece from being correctly positioned. Additionally, over-positioning may cause the workpiece to deform under the clamping force, thereby affecting machining accuracy. However, in certain special circumstances, over-positioning can be reasonably utilized. For instance, when the workpiece has good rigidity and the precision of the reference points and positioning elements is high, over-positioning can enhance the rigidity and the stability of the workpiece positioning. The veteran craftsmen at the Shenyang Machine Tool have, through long-term practice, fully demonstrated this dialectical thinking of balancing precision and efficiency. When faced with complex machining tasks, they reasonably adopt over-positioning methods based on the actual situation. For example, when machining large and heavy workpieces, to ensure stability during the machining process, they may appropriately increase the number of positioning points, using over-positioning to enhance the rigidity of the workpiece positioning, provided certain precision requirements are met. This is not a compromise, but a demonstration of engineering wisdom. By making a reasonable trade-off between precision and efficiency, they ensure machining quality while improving production efficiency. In the actual design of fixtures, we need to correctly assess incomplete positioning and over-positioning and take appropriate measures. For incomplete positioning, we must accurately analyze the degrees of freedom that need to be restricted based on the machining requirements of the workpiece, ensuring that the incomplete positioning method can meet the machining precision requirements. During the design process, it is essential to fully consider factors such as the shape, size, and the machining process of the workpiece, and to reasonably select positioning elements and methods. For over-positioning, we should first strive to avoid it. When designing the positioning scheme, it is important to arrange the positioning elements reasonably to avoid redundantly restricting the workpiece's degrees of freedom. If over-positioning cannot be avoided, we need to take measures to eliminate or reduce its impact. For example, the manufacturing precision of the reference points and positioning elements can be improved to make their fit more accurate. Alternatively, floating supports or self-aligning supports can be used, allowing the positioning elements to automatically adapt to the workpiece's errors, thereby reducing the impact of over-positioning. To better understand the incomplete positioning and the over-positioning, let's look at a practical example. In the machining of an automobile engine block, the top surface of the block needs to be milled. According to the machining requirements, it is only necessary to restrict the movement degree of freedom along the z-axis, Tz, the rotational degree of freedom around the x-axis, R, x, and the rotational degree of freedom around the y-axis, R, y. This can be achieved using an incomplete positioning method. By designing the fixture reasonably and using 3 support pins to position the bottom surface of the block, the aforementioned 3 degrees of freedom are effectively restricted. This approach simplifies the structure of the fixture and improves clamping efficiency. In another case, at a machine tool factory, when machining a large machine tool bed, due to the large size and heavy weight of the bed, over-positioning was used to ensure stability during the machining process. Multiple support points were arranged on the bottom surface of the bed, resulting in over-positioning. However, by improving the manufacturing precision of the support points and using floating supports, the adverse effects of over-positioning were effectively eliminated, ensuring the machining accuracy of the bed. The form of workpiece positioning is shown in the figure. In this lesson, we focused on learning about incomplete positioning and over-positioning within the fixture positioning principles of Project 2. Incomplete positioning is a method that restricts only certain degrees of freedom based on machining requirements. It can simplify the fixture structure and improve clamping efficiency. Over-positioning refers to a situation where a degree of freedom of the workpiece is redundantly restricted. It should generally be avoided, but can be reasonably utilized in special circumstances. We also learned how to assess and handle incomplete positioning and over-positioning, and deepened our understanding through practical examples. Additionally, we gained insight from the veteran craftsman at Shenyang Machine Tool, appreciating the dialectical thinking of balancing precision and efficiency. Making reasonable trade-offs is a demonstration of engineering wisdom. I hope that in your future studies and practice, you will be able to correctly apply the knowledge of incomplete positioning and over-positioning to design more reasonable fixtures.